Let's talk about a couple more different types of formulas before we look at our next example. In this section, we're going to be talking about effective rates of interest. And just like before, we're going to have two different formulas we're going to be looking at. One of them is going to be if we are given some type of compounding period. The other type is going to be if we have continuous compounding, so no end values in that one. So let's take a look at this first formula. If we are compounding things n times, then our formula for the effective rate is going to be R sub E. This R sub E on this left-hand side just stands for effective rate. We're not going to be plugging anything in here to the right-hand side. On the left, equals. In parentheses, we have 1 plus our fraction R over N, and the exponent on that big set of parentheses is to the power N. And then we're going to be taking that whole thing and we're going to be subtracting 1 from it. Remember, this is if we have compounding periods. Notice you see the N in your formula. The second one for the effective rates is going to be if we have continuous compounding. On the left-hand side, R sub E. Again, this R sub E stands for effective rate. We're not going to be plugging anything in this left-hand side. On the right, we have E to the power R, all of that minus 1. Let's go ahead and take a look at an example. In this example, we're going to be given information about two different banks, and we want to determine which one is going to be giving us the better deal. So which bank do we want to invest our money into? For Bank A, they're going to give us an interest rate of 4.1%, and they're going to compound monthly. Bank B is going to give us an interest rate of 3.95%, and they have continuous compounding. Now, let's go ahead and take a look at comparing the effective rates for both of these banks, so we can take a look at which bank we might want to invest our money in. For Bank A, when we're looking at the effective rates, notice we had compounding periods that were monthly, so we need the compounding formula that has these n values in it. For Bank B, when we're going to calculate the effective rate, we're doing continuous compounding, so we're going to choose that formula. Let's go ahead and plug in the pieces for both formulas, and then we can take a look at which one is the better deal. For Bank A, our interest rate was 4.1%. Written as a decimal, that's going to be 0.041. And if we're compounding things monthly, that means our n value is going to be 12. For Bank B, our interest rate was 3.95%. As a decimal, that would be 0.0395. Let's go ahead and calculate each one of these out. Here's the work for both parts of that problem. For Bank A, our effective rate came out to be 0.04177. I went ahead and wrote mine as a percentage, so 4.177%. For Bank B, we got 4.029%. So if we take a look at the effective rates, which one do you think is the better deal? Right, we're going to go with Bank A since it gave us a higher percentage.